My name is Naveed Ahmed. I am a Senior Director for Data Engineering and Machine Learning at Hearst Newspapers. My responsibilities are to build the data pipeline, data warehousing, and using that data to build data products and predictive data science. You might not have heard about Hearst, but you might have heard of names like San Francisco Chronicle or SF Gate or Houston Chronicle, or magazine names like Esquire or Cosmopolitan or Men's Health. So the company behind this is Hearst. It's one of the biggest media companies in USA. I'm here to talk about the work we've done with Hearst Newspapers. Hearst Newspaper employs about 4,000 people across the country. It focuses on local news, and it has about 40 websites and plus websites, and it's continuously growing. And you can find more information about Hearst at this link. And these are some of the name brands that I just talked about. You might be more familiar with San Francisco Chronicle newspaper in this California area. So this is sort of like our data strategy at Hearst Newspaper. It might vaguely look like the Maslow hierarchy of needs. So data is the essential thing. Without data, you can't do data science or business intelligence. So our strategy was to first build a data warehouse. And I'll take some minutes to talk about what we did with BigQuery. And top of it sits business intelligence, which helps inform people in marketing, editorial, and product to make decisions on historical data. And then using the same data that you can use to look at historical data, you can do predictive analysis, and then also build products using that data. Let's talk a little about BigQuery. So why centralized data? Is if you have all the data in one place, you can connect the dots. So if you have data sets of newsletters and Google Analytics and your content database, you can easily make connections, versus if they were sitting in different database, you'll have to, it becomes difficult. And it's efficient for users to go into one place to get that data. There's no duplication. You're not getting reports from one place and then two different places, and those numbers don't match up. And it's efficient in data warehousing. You use the same project management, product engineering, and QA, and consolidate your efforts. And most importantly, relevant to this talk is it's the foundation for ML. And why did we use BigQuery before this? People used to either pull reports from different systems, email them out. There were different databases, different data warehouses. So a couple of years ago, we thought that we need to consolidate everything into one database. And we chose BigQuery, and these are some of the reasons why BigQuery was chosen. It's based on Dreaml technology, and this stuff is on their website, terabytes in seconds and petabytes in minutes to be able to query that data. It's fully managed. SQL, lots of people know SQL, so easy to get people onto BigQuery. And now with yesterday's release of BigQuery ML, you can even do machine learning on top of BigQuery. So this is the technology stack for our BI platform. We're using ETL, using Airflow, BigQuery as our data warehouse, and Looker. And I think there have been other talks talking about how people have used Looker with BigQuery to build user journeys and stuff. So we're also doing it. That could be a separate talk, but I'm just mentioning that we are also doing this. And these are some of the data sources we have in BigQuery. Google Analytics, DoubleClick, subscriptions, newsletters, and this is continuously growing, the number of data sets in our data warehouse. So getting to machine learning. So I see machine learning in two big buckets. One, machine learning that's prepackaged, that Google has done your data science work for you, and they've exposed APIs to be able to do, and these are natural language processing, AutoML, which was also released in this conference, speech, video intelligence, and vision. And the other half is where you're data science and you're doing machine learning in-house using TensorFlow/CloudML, BigQuery ML, and using Dataproc and Spark. So there was a case study published back in November of how Hearst Newspapers is using natural language processing and the different use cases. So the two pieces that we've used from natural language processing is to be able to extract entities and categories from our text. There's a part of speech API that we haven't used, but this alone, we have about 6 use cases using these features. So I took an article from San Francisco Chronicle, this is about this movie Black Panther, and ran it through the web interface from Google. And you can see that it has correctly detected Black Panther as a work of art. It has a Wikipedia link. It also has the knowledge ID and also the saliency score. And the entities are broken down into different categories. There is work of art, places, organization, locations. And then that is further broken down into proper and improper nouns. And then it also correctly detected the right category for it, and also given the confidence score. So using just this is all good, but how do we use this thing? It looks very simple. I'm going to go through some of these use cases across as how to use Google NLP. You can, from a simple use case of displaying these tags on our CMS system to building a recommendation system, and also matching ads to the right content. So I'll go one at a time on them. And this is sort of like the high-level architecture of how everything connects. When content is ingested into our CMS system, we make these NLP calls, get the metadata back, and store it in our database. And then when the article is rendered, these tags are part of the meta tag of the HTML. And from that, we have a third-party customer data platform which is extracting these NLP tags into its system. And at the same time, there's a JavaScript call that to double-click for publishers to be able to render ads. And also, this data is pushed into BigQuery. Our CMS content, along with the NLP tags, are also pushed into BigQuery, upon which we can do BI reporting and then also build a recommendation system on it. So first use case, segmentation. Segmentation is that be able to identify a group of users, say which group of users are sports readers versus like food and wine readers. So our CDP platform has a built-in mechanism to be able to use these tags to create segments. And how these segments are used is that you can push marketing messaging. Like, let's say if you know there's a segment about people who like to read tennis news, you can push a newsletter using this tool. The other use case is DFP ad targeting. So I mentioned that we're making, in our key value pairs, we can pass in a key of the NLP category and the actual category that was for that page. So what this does is DFP, over a month, it can collect all this data, and then one can run reporting on it, telling how users and how ads were displayed across our content. And then if another customer says, hey, I want to have a campaign to target Olympics web pages, put my ad on Olympic web pages, they can create a campaign with a certain criteria, and now this vendor's ads or partners' ads can be displayed on Olympics content. So this is just a screenshot of how like the rules are set in DFP. Since this is a BI report, it uses Google Analytics, WCM content, and the NLP data to come up with some useful numbers. So basically in this report, it's showing for this category, these are the number of users who visited, and these are the number of articles in that category. And a simple ratio could show that a higher ratio would mean that this is something editorial should focus on, this category, write more content about it. And there's numerous different things you can do if you have Google Analytics, NLP, and content database. For example, you can create trend graphs about a certain topic or a certain personality, how are they getting more famous or less famous over the years, like content-wise. And this is another analysis of, so we get content from third parties, which third parties give what type of content, like does this source give us more sports content versus the other one? And again, you can build different kind of reports using this. So I'll get into recommendation systems. So why recommendation system important? So next, if you might have read Netflix values their recommendation at $1 billion. So in our context, if we could reuse older content, which is just sitting stale and nobody's using it or looking at it, this could increase engagement. People would stay on the website longer, which means more ad revenue, and eventually people might even subscribe. Right now, people tend to go to the homepage, and whatever links over there are, that's the content they can see. But if we can use our recommendation system to expose older content, that would be very useful. So these are 3 different types of recommendation systems that are supported by the Google Cloud Platform. So we did a content-to-content recommendation system, personalized recommendation system, and a video-to-content recommendation system. So since we had the NLP data with the content data sitting in BigQuery, it was a very low-hanging fruit to build a recommendation system. And the core concept of this is any 2 articles which have high overlapping NLP entities are related to each other. And this is essentially a big SQL with certain rules and conditions that we created, and it runs on a periodic basis, like every 20 minutes as new content comes in. We run this SQL. So let me show the diagram for this. We run that SQL on BigQuery, store that in Cloud SQL, and it's fronted by a Kubernetes web service layer to serve these recommendations. And from the front end, like there's a JavaScript call to render these recommendations. So, and that API call, they pass in the content ID, you find all the related content that's already pre-computed in Cloud SQL, a Postgres database, and rendered out. So, continuing on this concept, so this was actually a hack day idea. We had a hack day, and I did this prototype to see if we could extract anything useful from video. So we took our videos, extracted the sound using a FFmpeg tool that's open source, and used that sound to make a call to the speech API, which gives you back the text for that video. And then, you can run NLP on that text as well as combine that with the metadata for the video. And you'll get NLP tags back. So right now, again, just like our text content is just when we ingest the video content, we're storing the transcript as well as the metadata tags along with it. Let me back up. And what we did was that since we have these NLP tags, this powers another recommendation system to recommend videos to text. Since our text already has NLP tags and we've extracted these NLP tags from video, now we can build an in-house recommendation system. So this saved our company some money. Instead of buying like a video to text recommender, we just build using NLP and search technology to build our own recommendation system. So this project we worked in collaboration with our TV department. This is using TensorFlow. Talk a little bit about what TensorFlow is. You might have already heard it. Neural networks are back, and the current deep learning revolution is because of deep neural networks. They're bigger and hierarchical, and many of the Google products, especially in the AI, are based on TensorFlow. And Cloud ML is a managed version of TensorFlow. So we built an in-house personalized recommendation system. That could be like one whole talk talking about how the algorithm and how it works and the full architecture of it. But essentially, in summary, it's using scalar vector decomposition, and basically a collaborative filtering algorithm. And that algorithm is something that you can fit into TensorFlow because you can solve it through using gradient descent. And TensorFlow library helps you solve algorithms that can be put into a gradient descent problem. And it's basically looking at a user's history and also the history of people who have similar taste to it. And there's an open source implementation Google released using Google Analytics, CMS content, to build a recommendation system. I'll encourage you to take a look at it. It's a bit similar to what we did. And the high-level architecture is we're reading our content from content and Google Analytics data from BigQuery. And you see there's another advantage that all the data is sitting in BigQuery. Do some pre-processing, and then run this TensorFlow model. And then this TensorFlow model gets stored. That's the output of the TensorFlow. And it's fronted by TensorFlow serving. TensorFlow serving is RPC layer that helps you deliver the recommendations on this model. And then it's fronted by a RESTful web service layer. Some of the other use cases for TensorFlow is to do propensity modeling, forecasting, content virality prediction, build customer content, classification of content. So I also had churn modeling, and that's a use case that I built in BigQuery ML, and I'll be talking about it. So now Google offers you a variety of ways of doing machine learning. So it's a question of what makes sense is you have to figure out what makes sense to use TensorFlow versus BigQuery ML versus AutoML and all these other API. So I gave a talk about BigQuery ML yesterday. So why BigQuery ML for Hearst Newspapers? As I already told you, that all our data is already sitting in BigQuery. So this made a lot of sense to just do this using BigQuery ML. It enables anyone familiar with SQL to get on board and start doing machine learning. And the alternate would be to first learn R or Python, learn a framework like scikit-learn or TensorFlow. But over here, using BigQuery ML, you don't need to learn any of those. You don't need to ETL data out, do a machine learning outside, and then ETL stuff back in. Everything gets done in place. And goodies like a normalization and one-hot encoding, it just does it for you. And then you have other SQL syntax to get evaluation of your machine learning model right in BigQuery. So it's a relevant churn prediction. It's a relevant use case for media, because you might have heard people have choices, and it's hard to keep the subscribers. So if we could figure out a way or have some insight into the future of which subscribers are going to cancel, we could say. So I put a proverb: money saved is money made. Or subscriber saved is money made, and I thought of two more yesterday, so I'll tell you another one. So prevention is better than cure, and one in hand is better than two in the bush. So this just proves that I passed my English test. This gives you insights into the future of cancellation of subscribers. It's two-class, so it's a binary logistic regression, people who cancel and who didn't. And we took 1 year of data of our subscription, newsletter, demographic, web browsing. All of that data, again, is sitting in BigQuery. So the architecture is really simple. It's really two nodes, BigQuery and Looker. But I put in a few steps of what happens. So we're ETLing in all our data sets using Airflow, doing a little bit of pre-processing of our Google Analytics data, like making some summary tables, especially of how subscribers end up browsing. And then third step is the real machine learning step. You just do create model, the model name, and then you give it a table with all of the columns with the features, and one column is the label column. And the label in our case is, did this person cancel or not? And then when you run this query, it takes about 4 or 5 minutes. You go and grab a cup of tea or coffee. And when you're back, the query number 4 is you run select star from predict on a table which has existing subscribers, existing current subscribers. And for those subscribers, it'll give you a score of, a probability score of how likely they're to cancel. And then we built a dashboard and a bunch of looks in it, which show the output of the results, and also the output of our machine learning matrix, such as ROC or precision and recall. So this is a snapshot of a dashboard. So the first look is basically showing all the subscribers sorted by how likely they are to cancel their subscription. And somebody in the subscription retention team can take a look at it and at least have an idea of what this is predicting, do some forecasting. This number on the right side is the AUC curve. It's called area under the curve score. And it's essentially the area under this other graph. And it's a data sciencey thing, but what it means is that if this AUC score was 50%, then our machine learning model hadn't learned anything, meaning that this line over here, that's a plot of false positive versus true positive, would just be a horizontal line. But this shows, A, that our data has predictive power, and 2, that BigQuery ML is learning something. And on the right, we're plotting the same graph, which is the true positive rate and the false positive rate. So another problem you have to figure out is what probability, the probability threshold above which you say that this person is a churner or not. Do you say like 50% and above or 30% and above? So this graph over here on the bottom, on the right side, shows a plot of true positive and the false positive rate. And we want to have a threshold which gives us a decent true positive and also have a low false positive rate. So we chose some about 0.3, which gives us about 18% false positive and 80% true positive rate, which I feel is fine, because even if you send out emails to the people who you think are going to churn, and if they don't end up churning, it doesn't hurt. You just send out extra emails. And this is a plot of, so you can also get the weights of your learned model to get an idea what it's learning. So this is a plot of the weights of these things. So features that are on the left are positively correlated to churn, while the features on the right are negatively correlated to churn. And it gives us a sense that, let's look at this feature. There might be some clue in our historical data that we might be able to take some business decisions or change the way how we're doing business and reduce our churn. And it has two types of features. One is just numerical features, and the others are categorical features. So you have to do unnest in your BigQuery SQL to be able to get those other features. And you can look up at the BigQML tutorials with examples of other use cases to do predictive modeling. So AutoML for text was released in this conference. So while this was an alpha, I've been working with the product manager and built a model for ourselves. So we have two main use cases. The discussion about DFP, being able to match ads. We also want to enhance some of our categories. For example, take the sensitive subject category and break it down into more granular ones, or like if there's a new sports that's not covered by the default categories, we want to train our own. So that's one use case. The other use case is that I worked over here is to be able to detect evergreen content. And evergreen content is content that has a longer lifespan. For example, a review of a restaurant or a museum will call it evergreen content. But a story about some accident that happened in a mall, it only has a few days or a few weeks life. So you want to be able to differentiate content that's evergreen or not. So initially, I tried this open source data set from StumbleUpon, from Kaggle. Very initially, I tried to write my own TensorFlow code using LSTM. I just quickly prototyped it, felt that the data had predictive power. But I knew that I had some hunch that Google was working on something like this. So then we created a data set of our own data set to label evergreen content. So it was sort of like internally crowdsourced through our CMS, where editors basically tagged some of this content as evergreen. And to use AutoML is really easy. You create a CSV file, give it the first column as the content, and the second column as the label, evergreen or not evergreen. And then upload it to AutoML and have it learn from this data. So you see this, we had about 3,000 articles for evergreen and another 3,000 for non-evergreen. And you see it has done a pretty good job in learning this thing. I was surprised that it could do so well. And you see the precision recall score, and it also shows the confusion metrics of what it predicted. 91% of the time, non-evergreen content it predicted as non-evergreen, and only 9% of the time it made a mistake for non-evergreen content. And for evergreen, it did a perfect job. And this is only on their test set database. So I took this and I played around and tried. In the AutoML console, you can put in any random text and see how your prediction model does. So I tried it on our Hearst articles. I tried it on CNN articles, and it seemed to work very well. And then I even went to Wikipedia. So I picked up an article about New York, so that you think is evergreen. And 70% it predicted that this is evergreen. And then again, from Wikipedia, I picked an article about Mexico elections, and it predicted it's non-evergreen. So it's basically the combined knowledge of editorials of what they think is evergreen and non-evergreen. This AutoML has learned and is able to apply on text that it hasn't seen before. So ideally, we want to use BigQuery for most of our analytic process. Anything that can be formulated as SQL, I tend to want to use BigQuery because it's distributed and it's more cost-effective to do things in BigQuery. But there are some use cases that like very few use cases that you have to do things outside of BigQuery. So one of the use cases that we have duplicate content, content which either their body looks very similar or the headline is tweaked, and essentially it's the same article. And we don't want to recommend articles that are similar to each other in a list of recommendations. So, and what we wanted to do initially was in BigQuery, like create a word-to-vec of each article, and then do a cross-join with itself and figure out the distance between those articles. And doing this in BigQuery was not possible because that query wouldn't return. So what we did is, in this use case, we used Spark. Basically, spawned up a cluster of 10 machines for a couple of hours, and we wrote a PySpark job to compute these vectors and basically compute the cosine distance between articles. And articles that were very close to each other, we eliminated them as duplicates. This helps our recommendation system to remove any duplicate content, and a use case of Spark and Dataproc in our data. So I'm getting close. This is actually my last slide. So what's the future of Hearst Newspapers? So we want to build more predictive models using BigQuery and ML, because it makes a lot of sense since we all have all the data and it's very easy to use BigQuery ML. Things like propensity modeling, like the reverse of churn modeling, is to figure out who are the subscribers that are likely to subscribe, or who are the visitors on our web pages who are likely to subscribe. And this could help our marketing systems, like focus on those. And actually, in yesterday's BigQuery demo, the demo was about figuring out those people that are likely future customers. We want to productionalize the taxonomy I was talking about. We already have requirements to, and AutoML, we want to create our own data sets and train it to enhance the NLP taxonomy. There's been lots of research using deep neural networks for recommendation systems. There's actually one article which lists all the different research papers using deep neural networks for recommendation system. And we've been prototyping a few different approaches. Like there's hybrid approaches. There's all sorts of different flavors of doing recommendation systems using deep learning. So that research is continuing, and hopefully our version 2 will be a even more advanced recommendation system. There's still more juice to be taken out from Google NLP. We haven't fully utilized the NLP, especially some of the use cases are being able to build personalized newsletters or topic pages using Google NLP. So we are thinking on these other use cases and how to productionalize this. And also we have a large corpus of images. Haven't yet reached that point to build a product around it. So that's one of the things that I have for the future.